I'm Zachary Kircher, and this is my modified tutorial 6 and 7. I will begin with the physical circuit. As you can see, we have the transistor and the motor from the original tutorial, which use the transistor and a code to alter the speed of the motor. Looking at the modified circuit, I have added 3 buttons, which are momentary contact switches, which close the circuit when it's pressed down, as well as a piezo for sound. This works by converting alternating electrical current into vibrations which produce sound. These 2 buttons control the speed of the motor, this being the accelerator and this being the decelerator. They work by using the board to read when the button is high or pressed and increase or decrease a variable in the code. This button controls the piezo, which simply sends a high or low analog value to tell the piezo to either make sound or not make sound. Next, over here we have 6 LEDs, or light emitting diodes, which light up when electricity passes through them. 2 green, 2 yellow, and 2 red. These are used like a speed gauge and turn on in order based on that previously mentioned variable. Another component is this flyback diode, which protects the Arduino board from the current coming from the motor. The transistor, which can either be used as a switch or an amplifier, is an NPN, or a negative, positive, negative, with the base being in the middle, the collector being on the right, and the emitter being on the left. There are also an assortment of different resistors with different resistance levels. These limit the flow of electricity in the circuit. We have a basic hobby motor, which spins when electricity is sent through it, and finally I am using a STEM-Terra board, which is a combination of a basic breadboard and an Arduino One board all in one, which allows for more compact and organized designs. Shifting over, you can see the working circuit in the top right corner, but now we're more focused on the serial monitor, which is displaying the analog values of the buttons. The values change as I interact with the circuit. I've slowed it down to a second delay so you can see the printouts, considering they go kind of fast at 10 milliseconds. So as you can see, as I hold this button down, the value of button 2 changes in the serial print. And when I hold this one down, the value of button 1 changes to 0. And when I hold this button down, the value of button 3 changes. Now we're going to move away from the physical components of this circuit, and we will start by taking a look at the schematics. Here you can see the different symbols I displayed previously while talking about the parts. Here you can see the resistors and the LEDs, which are connected to the power and then back to the ground. Same with the buttons, however you can see the resistor just connects it to the power, whereas the wire is connecting it to its port on the board. Here you can see the motor, transistor, and flyback diode in the circuit, and you can follow the flow of power as it comes through the motor, through the transistor, and back to the ground. Finally, we will take a look at the code which allows this circuit to execute all the actions. To start, we will assign a variable called counter, which will allow us to easily change the speed and light up the LEDs in order. It will start as 0 as its starting value. We will also assign all our components to the different ports on the Arduino board. Next, in void setup, we will start by setting up the serial monitor, which will allow us to constantly monitor the values of our buttons. Then, we will turn the LEDs, the piezo, and the transistor all as outputs and the 3 buttons as inputs. Moving down, we get into the void loop, which is where all our consequential code is. This will be the stuff that tells the circuit what to do. I started by assigning values for the analog and digital readings for the buttons and the motor, which allows the serial monitor to print them. Then, you can actually tell the monitor to print it with a delay to ensure it isn't too hard to read. Here you can see the code for the horn, or the 3rd button. You can see that as you press it and it reads the value of high, it tells the piezo to play a sound at a tone of 1000 Hz. And if the button isn't pressed, there shouldn't be any noise coming from the piezo. Next is the code for the decelerator, or the second button. This works by subtracting a value of 1 digit from the variable counter, which will affect the if statements below. The same is the case for this if statement, except this is the accelerator and it adds a value of 1 to the counter variable. Here is the effect of the addition or subtraction to the counter variable. These if statements use equal signs to constantly check if the statement is true, and if not, move on and continue to the next if statement. However, if that statement is true, it stops and runs the conditional code inside the if statement. Here you can see that if counter is 0, then all the LEDs are off or low, and the motor has no speed. Then once you press the accelerator and the counter equals 1, then you have the first LED turn on and the motor speed increase in small amounts. This continues as you press the accelerator, and the opposite happens as you press the decelerator, and the value decreases. This 7 isn't related to the speed or LED, but instead is stopping the counter from going past 6, which would have resulted in the motor stopping. And that is the end of my tutorial 6 and 7.